Hello guys, welcome back to our Advanced RAG application series. In this lesson number 2, we're diving deeper into building efficient and scalable retrieval augmented generation pipelines. Today, we are covering some powerful tools and techniques including Milvus Lite, a lightweight vector database that helps us to store and search dense embeddings quickly. Hybrid search will combine sparse keyword based and dense semantic based searching using Milvus for more accurate results. And coming to the embedding model, we are going to use BGE embedding model, a cutting edge model for generating embeddings that capture the nonsense of your data. And final one is Grok LLM. We'll integrate this to enhance our query understanding and response generation using Llama 3.1 70 billion parameter model. By the end of this lesson, you'll know how to set up a hybrid search engine using these to supercharge your RAG pipeline. If you haven't seen lesson number 1 yet, where we explored advanced RAG with Pinecone, reranking, and Grok, make sure to check it out before or after this video. So guys, don't forget to subscribe to this channel for more deep dives like this. So now, let's get started. So guys, in the RAG series, till now I made 4 videos. In the first video, I talked about simple RAG, and then I come to the naive RAG. After that, intermediate RAG application, and the recent one is advanced RAG lesson number 1. So now in this video, I'm going to talk about advanced RAG lesson number 2. So guys, now let's understand advanced RAG lesson number 2 flowchart. So let's begin with loading the PDF. So first we are going to load the PDF with the help of PDF plumber. After loading, I'm just extracting text from the PDF and then embedding it with the BGE M3 model. So after embedding, we'll get sparse vectors and dense vectors. So I need to store these sparse and dense vectors. So after getting these vectors, I have to store this. To store this, I have chosen Milvus Lite. In the Milvus Lite database, I'm just storing sparse vectors and dense vectors. After storing, we'll get the SQLite database. So with the help of Milvus, I'm going to perform hybrid search on this. Hybrid search is the combination of semantic search and keyword search. In the dense, we have semantic search. In the sparse, we have keyword search. So in this video, I'm going to explain sparse vectors and dense vectors also. So in this hybrid search, with the help of ANN search and rerank, we are going to get the content. So in the last video, I took reranking model from the Cohere. But here there is no need to add the rerank model because in the Milvus hybrid search process, first it is going to identify the semantic search. After that, it is going to re-rank the documents using the weighted re-ranker. So in this video, I'm going to explain that part as well. So after retrieving the content, we are just passing it to the LLM model, which is Llama 3.1 70 billion model. So now the model is going to give us the response. So what change means, in the last video, I just added the re-ranking. But in this video, I'm adding hybrid search. But here there is no need to add the re-ranker. The Milvus is providing the re-ranker as well. You got it right? So previously we have only the sparse vectors. But here we are creating dense vectors as well. So guys, basically assume that hybrid means keyword search and semantic search. For keyword, we are going to use sparse vectors. And for the semantic, we are going to use the dense vectors. So now the flow is completed. Let's begin the coding. We have to go through the flowchart only. So first one is we have to install this package. Just pip install. It is going to install all the packages that are required to this project. I'm just installing. You can see I'm installing Milvus Lite, Milvus model, Langchain community, and PDF plumber. For now, later in this video, we are going to install some other packages, but those are not required for now. So meanwhile, I load my PDF, data science PDF. You can see guys, downloading package has completed. Now here I took the data science PDF, but you can take any of your PDF. So guys, you can see the downloading has completed successfully. Now we have to load and prepare the data. So from Langchain community.document loader, you have to give the path of your PDF. After that, load docs. So here I'm going to load the documents. I'm going to load the text from the PDF. So when you execute this, first it is going to give you the number of pages in the PDF. There are totally 37 pages are there. After that, we have to extract text from the each page for embedding. So with the help of this line, I'm going to extract the text from the, here you can see it is a complete text that we extracted from the PDF. You got it right? So now loading part is completed. Now we have to embed the documents. After embedding, we'll get sparse vectors and dense vectors. So from the Milvus model.hybrid, import BGM3 model function. After importing, we have to initialize the model. Function BG embedding function floating point equal to false, device equal to CUDA. So guys, here you have to choose the T4 GPU, then only it will work, or else you have to replace it with the CPU. So now I want to run this. Let's wait. First it is going to download the model and then it will embed the text. See, start to install package datasets. So guys, you can see downloading the model is started. It will take some time, so wait for that to complete. So guys, why I am taking this model means it is a famous model. In the last videos also I explained this model clearly because it is a famous model and which is open source model. See guys, it is giving this doc text is not available because I haven't run this code yet. It is my bad, sorry for that. Let me run it again. Now you can see it is embedding the doc text. The embedding has completed. Now I just want to print embedding. You can see guys, these are the embeddings that we got with the help of model. See guys, here we don't need to create separate dense and sparse vectors. When you embed your text with this model can create dense and sparse vectors. Here you can see these all are the dense vectors. And now here you can see this is the sparse vector. We can't see the sparse vector for now. Embedding also created. So now we have to learn about sparse vector and dense vector. So now let's see the difference between sparse vector and dense vector. So guys, basically in the machine learning we use sparse vector. In the deep learning we use dense vectors. So the sparse vector in the machine learning we use it for keyword search. For example, bag of words, TF-IDF, where we can use it in the machine learning models only. So now let's see the representation. Counts of the word in the text. But here it is going to identify the semantic feature learned by the model. Example. These are basically 1 or zeros. For example, you can see in the bag of words or one-hot encodings, where we can have the only ones and zeros. But in the dense we have the floating points. Coming to the dimensionality, equal to the vocabulary size. If you have big vocabulary, then it is going to create big dimensionality. But here you can see it is a fixed dimensionality, 384. For example, in the last video, we used nomic text embedding. That is 768, I think so. I'm not sure about the numbering, but that is a dimensionality. So it is going to create the vectors in the same dimension. But in the sparse, it is going to create vectors based on the largest vocabulary or largest sentence, I think so. Sparsity. Mostly zeros for large vocabularies. But here, mostly non-zeros values. Because it is going to identify the semantics. So that way, to identify semantic, it should do some calculations. Further, we'll get floating points only. But here, that is not required. But here, it won't happen. Directly ones or zeros. Next is interpretability. High. Explicit word counts. Because we have more word counts here. But here, low abstract features. And the final one is use cases. Simple for text classification and TF-IDF. But it is for semantic search and similarity matching. So that's why most people prefer only for the semantic search or hybrid search in these RAG applications. So now let's see the simple definition of sparse vector. It represents the frequency of words in a document using fixed vocabulary. It is simple and interpretable, but it does not capture the context or meaning of the words. We are already aware of this one in the machine learning. It doesn't capture the meaning of the word. So that's why we went to the advanced concepts like LSTM, GRU, encoder, decoder, like that. Dense vector embedding encodes rich semantic information about the text using a fixed size vector output by a neural network model, making it useful for tasks like semantic search and text similarity. So basically, it is going to identify the similarity. So now let's see the sentence similarity between two sentences. Here I choose sparse embedding and here I choose dense embeddings. So now let's see the sentence number 1. How old are you? That means it is asking for your age. And the second one is what is your age? It is also same. But we can understand there is a same meaning for the two sentences. So let's see the similarity. Here you can see the bag of word has given 0 similarity. That means how old are you? These are the 4 unique words. And the second one is what is your age? So this word and this word is not matching. So that's why it gave 0%. But when it comes to the dense embedding, but you can see it gave 91% matching. Because this meaning and this meaning is same. We already know. This parse is not able to capture this meaning. So that's why we got the dense embedding. It is going to capture the meaning of the text. And the second one is how old are you? And then let's see the second example. First sentence is how old are you? And the second one is I don't know. I can't pronounce it, but I took it for example. See here, it is also, here we used same language, but here we used different language. But since it gave 0 similarity, where it compared to the dense, it gave 84 similarity between these two sentences. You can see. So guys, it is a beauty of this model. Because the BGE is built on top of 100 languages, it is going to identify the similarity between 100 languages that I explained in the past video as well. If you watch that video, then you can able to grasp this easily. You got it right? So guys, successfully we have completed third step also. Creating sparse vectors and dense vectors are also completed. So guys, the third step is completed. Now we need to store the sparse and dense vectors into the Milvus Lite vector database. So for that, you have to install this package. From PyMilvus, import connections, utility, field schema, collection schema, data type, and final one is collection. So now I'm just going to connect to my Milvus DB. So for now there is no DB is created. So it is going to create the DB here. After that, fields. I'm going to define the fields. Field schema equal to, first we have to use the auto generate ID as a primary key. So the primary key is created. Is primary equal to true, auto ID equal to true, max length equal to 100. And the second field is text. Data type equal to varchar and max length equal to 2048. Now we have to give the field name for sparse vector and dense vector. Data type dot sparse vector and data type equal to float vector. But here I already told you for the dense vector we have to give the dimensions. So here I give the dimensions what I took here, dimension. So let's see what is the dimension 1024. Now schema equal to collection schema. So I'm going to create new schema with all these fields. So it is going to create the schema for us. After that, I'm going to create one collection. It is going to drop the old one if exist. So guys, for now we have created this one. I just want to download this. Now open the VS Code. So guys, I already told you you have to install SQLite viewer. So now I'm going to paste this here, Milvus Lite 1DB. So guys, you can see for now we have created this one, this schema. So guys, you can see here the DB is created. So now I want to create one collection. Collection name equal to hybrid demo. If utility has collection call name drop. It is going to drop if any collection is exist. Now collection name schema consistency level equal to strong. To make vector search efficient, we need to create indices for the vector fields. Same guys, you can see sparse index. For sparse, I just give this name, sparse inverted index matrix equal to IP. Create index. It is going to create the sparse index. Like that same. Dense index. For dense, index type equal to auto index. See, it is going to create the collection. So the collection also created. Now insert data into the Milvus collection. Same guys. Batch text equal to, I'm just passing the text. After that, sparse vectors. Docs embedding sparse. When you give sparse, it is going to get only the sparse. When you give dense, it is going to get only the dense. Now in the batch entities list, I'm just passing these three variables: text, sparse vectors, and dense vectors. Now call dot insert. Insert batch entities. It is going to insert all this into this hybrid demo. Let's do it. So guys, you can see number of entities inserted 37. It just inserted 37 pages of context because we have only the 37 pages in the PDF. Now let's download this DB. I just want to copy this one. Paste here. Milvus Lite 2DB. So guys, I already told you to install SQLite viewer. So guys, first we have created this collection meta. So guys, you can see first we have created one DB, right? So there we gave primary key, sparse vector, and dense vector. Here you can see this step. Now after that we have created hybrid demo. Let's see the hybrid demo. You can see guys, ID, Milvus ID, and the data. I hope it is clear. So now let's come to the flowchart. Now we have to focus on the hybrid search. In the hybrid search, I'm going to add ANN search and re-rank documents. Let's begin that. So guys, before going to that, I just wanted to show you my PDF. So guys, this is the PDF I have. So guys, now I just want to try one question from this PDF. What is resampling? When resampling is done, run this, paste your query. Now run the search. We'll first prepare some useful functions to run the search. Then search. only search across dense vector field. Sparse, only search across sparse field. Hybrid search, search across both dense and vector fields with a weighted reranker. So from Milvus import ANN search request and weighted reranker. So first I'm going to create one dense search. Here collection very dense embedding limit equal to 10. It is going to get the 10 matched documents. I just want to give it 5 here also. Now same guys, search parameter is equal to matrix type IP and params equal to this one. Now call dot search query dense embedding. So here we are just passing the embeddings of the query. That means question. ANN fields dense vector limit equal to limit output field equal to text. We just need to get the text only, not the vectors. Params equal to search parameters. Now 0. Index equal to 0. Return hit dot get text for hit in response. Let's run this. Here also same syntax. Now for the hybrid search, I just want to give the 5. So guys, you can see I gave the very dense embedding, very sparse embedding, because for embedding also it is different. Here I just give query sparse embedding, query dense embedding. That's it guys. Remaining is same. Now sparse weight equal to 1, dense weight equal to 5, limit equal to 5. See guys, here I'm using ANN search request, after that weighted rerank. So for the dense and for the sparse, I'm just using the same ANN search request. After getting that, weighted rerank are equal to sparse weight and dense weight. Hybrid search, call dot hybrid search, sparse request, dense request, rerank equal to rerank, limit output field equal to text. Same index equal to 0, return it dot get text for hit in res. So guys, for now you have understood. I just used 3 methods: ANN search, weighted rerank, and then hybrid search. So now let's understand about these 3. Now we'll begin with Milvus hybrid search. A hybrid search uses hybrid search API to perform multiple ANN search requests in a single call. Each ANN request represents a single search request on a specific vector field. Now create multiple ANN search request instances for similarity search on the different vector fields. So the ANN search is going to search for the similarity. You got it right? Similarity text from the dense and sparse. And configure a re-ranking strategy to combine and re-rank search results from multiple ANN requests. We just need to configure. So we have already done that. After that, ANN search request. A class representing an ANN search request. Each hybrid search can count 1024 ANN search request. At a time, it can send this many requests. After that, weighted re-ranker. It is used to assign importance to the result from the vector field. From each vector field, search with specified weights if you prioritize some vector fields over other fields. So guys, let's come here. We are given weight equal to 1 and 1. So according to this, it is going to re-rank based on this weight. You got it right? So guys, when I call this function, I just want to, so guys, I need to execute this one. You can see it is executed. So guys, here I'm just running all these 3. So before that, I want to print all these 3. Let me cut this one. These are the dense results. These are the sparse results. And these are the hybrid results. Now, to display results for dense sparse and hybrid search, we need some utilities to format the results. So guys, just forget about this completely. What it does means, so when I give this dense results, it just elaborate this context. So it is going to elaborate this content. You can see guys, here I got in this single line. I can't see much, but here you can see it clearly. That is the difference. Now I just want to run all these 3. So guys, now let's come back to this PDF. The question, the answer started with resampling is a methodology and ended with text. Now we have to search for this answer. So guys, now you have to see. See guys, it is the dense results. Resampling is done to methodology. Start with resampling and performing test. You can see guys, our answer is there in the dense vector. Now let's see whether our answer is there or not. See, in the sparse also our answer is there. Okay, it's clear. And then in the hybrid, our answer is there. So guys, here I want to convey one thing. I just took one PDF only. So when you want to go this, you have to at least try to use 10 to 20 PDF. Then only you can able to identify whether it is performing good or not. Here I took only one PDF. It can easily find it out. But there you have to give multiple PDF with multiple pages like that. I hope you got it. So guys, it is only for the educational purpose. So guys, you can see we also verified it is getting the content. You got it right. And one more thing, the results depends on the embedding model also. Here we use the famous embedding model also. It is also a good option. And also Milvus is performing ANN search. It is advanced technique. It is going to identify the similar context, similarity meaning. So guys, now the final step is we have to give this to the model and then we have to get the answer from the model. So before that, we have to define a prompt template. Final prompt. So guys, defining the prompt template has completed. Here I just define only the simple prompt template, but you have to work on prompt template and you have to see the results and then based on that, work on the prompt template. It is very important part. You can see guys in the prompt template, in the final template, I'm just passing the question and the hybrid search results. Question equal to query and then retrieved information equal to hybrid information. You can see here I'm printing the final prompt template. Now you have to install this Langchain Grok. In the last video also I explained this concept. So guys, now I have to come to the Grok and create one new API key. After creating API key, just come to here in this code, Grok API key equal to your API key. That's it. After that, you have to define this chart completion. Line.chart.completions.create messages. First, we are defining role equal to user and content equal to final template. Model equal to, I just give this model name. But you have to choose your own model from these models. So when I execute this, I got this response. It is not giving the exact information, but it is kind of summarizing the user question and then giving the best summarized answer. So now we have to read this answer and compare this answer. It is the answer that I got from the model. So now I just want to read my PDF answer. Resampling is a methodology used to sample data for improving accuracy and quantify the uncertainty of population parameters. It is done to ensure the model is good enough by training the model on different patterns of a dataset to ensure variations are handled. It is also done in case where model need to be validated using random subsets or when substituting labels on the data points while performing test. Now we have to read this model answer. Model is kind of summarize the answer in a correct way. I think resampling is a methodology used to sample the data for improving accuracy and quantify the uncertainty of population parameters. It is done in these following cases. You can see guys, first line it took the same because I told model to use only the content which is given in the retrieval information. Now it is done in these following cases, improving the accuracy. So for this step, it just elaborated, improving accuracy. Resampling is done to ensure that model is good enough by training model on different patterns of dataset to ensure variations are handled. You can see guys, it just took this point and then reframed it. Now model validation. It is used when model is need to be validated using random subset. You guys, it just pick this one. Now substituting labels on the data points. Data points. Resampling is also done while performing test, especially when substituting labels on the data points. It just took the but it rewritten it to the understand to the humans and also it just gave in a better format. Now additionally, resampling can done in case of imbalanced data where the data set is distributed unequally across different categories, resulting in an error in model performance or inaccuracy in context data analysis. It gave the other information. It is also required for resampling. In our document, we have only the limited answer, but the model has give some more extra content to us because here I use big model, 70 billion model. So when you go for this small model, then you can see some difference in the response. Always, when you are going to the production or advanced RAG, you have to use the big model only. For example, GPT, Anthropic, and this Llama 70 billion, 405 billion, 90 billion, like that. Defining the model is based on your use case. Sometimes you have to fine tune and then perform RAG. It is also a good option when your task is completely on the domain specific. You got it right. So guys, Our complete flow has completed. So guys, bye for now. See you in the next video, another topic. So till now, please take care and then subscribe to my YouTube channel.